Alrighty, well thank you guys for coming out to the last LVTech meetup of 2015. At least I think it is. I don't think there's anything else scheduled. I hope there's nothing else scheduled because I don't know about it if there is. As always, we want to thank Ben Franklin for being such wonderful and gracious host. That guy in the back, kind of looking at you all, making sure that you don't drop your pizza on the floor. That's Wayne. Let's give us a wave. Wayne is responsible for letting us in here. We are responsible for any damage that happens tonight. That's pretty much how it's sliced this evening. So, let's see what else we got here. How many of this is your first LVTech meetup? All right, a few. Bill Spain. Could have sworn I'd see you before. No? All right, so it's Bill's first meetup. So we do this every month-ish or so, and there's also some social meetups that happen as well. And I encourage you to go to our site. You can find us at LVTech.org, or just go to Meetup and search for LVTech. You'll find us. That has all the fun information about what we're doing. Generally, we have a meetup that has 3 or so presentations, 10 minutes of a presentation, 10 minutes of Q&A. This one's a little bit different because there's a huge robot right in the middle of the room. And there's also a bunch of multirotors over here on the table. So this is perhaps a unique meetup for us, but I thought it was a cool way to end the year, and I think you'll all find it pretty interesting. I'm trying to think if there's anything else I'm supposed to say at the beginning. I'm completely unprepared for this, which is about normal for LVTech stuff. How many of you listen to our podcast, the LVTech Radio? All right, one person. So we haven't been doing it a lot. Two people. Like I said, Anthony listens to it live in the room. So we didn't do that. We normally do that before every meetup, but we didn't do it for the past couple months because I've been busy. But if you do follow that or want to follow that, it's at radio.LVTech.org, and we should have more content there next year. So without doing much more, I'm going to play a video that FabLab wanted me to play that introduces what the FabLab. How many of you have heard of the FabLab before? Oh, you didn't need this video. You know it's all right, I will turn this now over to the FabLab team robot people. So, Brian.
Okay. All right.
Don't break anything.
Don't break anything?
That's the challenge.
Okay. The reason they're saying that is because we have had the robot arm out in the hallway at the Fowler Center, and in raising it, we kind of punched through one of the ceiling tiles. So there's a little bit of a crack in there, you can see in the hallway.
Don't tell the story when Wayne's in the room.
He already knows about it. So I was also informed that these lights are $3,800 a piece and we're not to break any.
$3,900.
39?
Yes.
That's why Anthony's going to be wearing a glove. And I said to Jeff, well, don't worry about it because we're the FabLab, we'll just make him a new one. So, this is our robot arm, it's Tobor. The story behind it was we have a guy who's associated with the FabLab named Peter Lowe, and he is now at Stanford in California for a master's program. And he got accepted into the Bay Area Maker Faire for a 6-inch tall robot arm with haptic feedback. And we decided, well, wouldn't it be cool if we built a 6-foot tall robot arm with haptic feedback? And that's what we did. So we designed it to showcase everything that we did at the FabLab, all the different specialties and talents that we had. We have, some woodworking stuff there on these little wooden end caps. We had a wooden base that we have since replaced. We have carbon fiber. We have machine parts. We have a lot of electronics and robotics. We have sound in there. We have speakers. And we got laser cutting stuff, and then casting and 3D printing. So everything that we can do with the FabLab is encompassed in here in some way, shape, or form. We got this done, the initial rendition, in 7 weeks. It was a stretch goal. We barely had it together. The night before, we had to put it in a minivan and haul it out to California, and had to do a cannonball run to get it out there so that it was set up in time for the Maker Faire.
You're finishing like 3 a.m., 2 a.m. a couple days beforehand.
And then the instruction was, pick up the van at 9 a.m. tomorrow so that you can leave and make it to California in 3 days, which we did.
Somehow. It's kind of all blurry.
Luckily, Tim was driving the first couple of stretches, so we were all right. We got some sleep.
I think we're ready to...
all right, are you hooked up?
I think so. I got the... So, here goes. Going hot. Usually takes a minute or two to power up for the wireless connection to make that first contact, but once it does... see the motion of my hands actually gets copied over by the robot. The accelerometer in the glove itself is what's controlling the elbow, and then in my wrist it's controlling the shoulder.
It's light.
Yeah. I gotta be careful with the shoulder. We can also turn it a little bit to the left or the right by rotating the wrist. And the sounds that you hear are synthesized out of a combination of a couple of found sounds, little bits and pieces from movie clips, as well as synthesized noises out of like you would get out of a keyboard or a computer program. And then the gripper itself is controlled with a flex sensor inside the glove itself. So when I close my fingers, the gripper will shut. And then once it actually makes that contact, and we do get a sound feedback, as well as there's a little vibration in the glove itself, so I can actually sort of feel what's going on there too. So it's a little tricky to use, but what I'm going to try and do is I'm going to try and pick up our little friend there.
We're not going over.
All right, I think. Yeah. There we go. All right, here, let me see if I can hand it over to Brian. There we go. There's a little delay in the hand, I've noticed. Yeah, the hand might be stuck as well.
I got it.
The gripper itself is actually the weakest point in the robot itself. The arm itself can lift up about, like 40 pounds or so?
Yeah, we put a cooler full of drinks on the end, and it'll pull it up. The big issue you have when you're lifting that much weight is that the base will start to rotate on you and things will start to fall over. We almost knocked over a 10 at the New York City Maker Fair.
Almost being cool.
Instead, the arm fell on top of me.
Yeah, that was fun. We've all kind of been injured by it, at least a little bit. Tim has not. I got pinned to the ground at one point. That was fun.
Okay, so the way Anthony's explained a little bit about the glove, we have 2 accelerometers in here to get the degrees of freedom we need for base rotation, the elbow and the shoulder joints, and then the flex sensor here for controlling the gripper. And that's running on an Arduino Pro Mini. And all our communication is done wirelessly using XBs. We've actually had Digi, the maker of the XBs, contact us and feature us in their blog. So this is wirelessly sending a signal to the main controller down here, which is running on an Arduino Mega and another XB. And that's sending signals to their soundboard, which is using another XB. And then the gripper is also using one as well. So the robot arm, Tobor, if you haven't figured out yet, Tobor is robot backwards. The robot arm is really never in a state of completion because we're always looking to improve things. I mean, we've changed the base. We're hoping to put a gripper on there with more digits, more fingers for more manipulation, make it easier to pick up. You know, we added the back there now, which was Jeff's idea, which is really cool. He has iPads in the back there that have an eyeball that kind of shows things. We're going to put a projector in there as well that would shine down, but the projector we got isn't really terribly bright. What else do we want to do to it? So it keeps getting bigger. Oh, we 3D printed these spirals here as well.
There's a little bit of robustness to the shaft.
And every time we make an addition, it gets bigger and harder to move. And then we're also working on redesigning the glove as well to make it a little bit easier to take on and off.
Since right now it's kind of a process, you might have seen me fiddling with it for like 5 minutes.
Yeah, Tim has a couple of the parts for the yeah.
Cool. All right.
Any other stories you want to? Anything we need to tell about the trip, or do you want to keep those under wraps?
No.
Okay. Oh wait. Not even the Bonneville Salt Flat story?
No,
So we did bring back a souvenir for Jeff when we were on our trip out to California. We stopped at the Bonneville Salt Flats and figured, well, what can we bring back Jeff? So we got Jeff a hunk of salt, and while we were out there, we had the minivan out on the salt flats, just a couple of feet because it was too wet to really get it that far out, but we got pictures to make it look like it's out in the middle there. And unfortunately, that got the van salted up enough that I had to go to a liquor store and buy a $7 bottle of wine so I could get $2 in change to go to a self-serve car wash and clean off the evidence. So
I didn't know that.
you've heard that story before.
every now and then, sometimes it'll get stuck in like one particular command and might go in a circle or keep going up forever, but you just got to turn it off and reset it. I think
it needs a little bit of refinement.
we figured out that it had a lot to do. We figured out that it had a lot to do with wireless interference. We would notice that it would be a lot less responsive when there are a ton of people around with a lot of wireless devices and stuff like that, like at the maker fairs and stuff like that. Everyone's walking around with their tablets and their iPhones and all that good stuff, and so as a result, the wireless communication got to be a little bit choppy. But on a quieter setting like this, it should be a little bit, should have a little bit more control. We're trying.
Well, one of the other things we did after many incidents was we put some reverse kinematics in there so that if you have the robot arm all the way in the down position, you cannot slam the hand into the floor.
Come on, so close. Oh. That's it. Thank you for the help.
There you go.
Close. And up. There you go. Merry Christmas. Anyone gets their presents delivered by robot. I'll see if I can set this down gently. It's actually kind of one of the hardest. About as gently as I can manage.
Golden piece.
There you go. All right. Cool. Any other things we want to talk about?
I just like to, I just want to say that I just complimented 14 of the instructors got together and built this thing in 7 weeks. 14 of the instructors got together and built this in 7 weeks. It was the most incredible experience of my life, really. I mean, it was every single night was a tragedy and then also a triumph. So one minute we were completely bummed out because we knew it wasn't going to happen. The next minute we were like a touchdown. It was really wonderful. And to see it just take off for 3,000 miles to go to California, and I had to sit back, and not go. It was really rough to see it from the sidelines, but really proud of these guys. So we're just going to keep on moving with all kinds of projects that are going to take up, all of the processes and so forth that we are including in the FabLab. So it's really neat. Good job.
All right, any questions? You said it was haptic feedback?
Haptic feedback, yeah. The glove itself has vibrating motors in the fingertips here. So when the gripper grips something, the servos that are controlling the gripper actually return the torque values that they're feeling from the gripper. So when they get high enough, wirelessly it feeds back there and it starts to vibrate the glove, so you pick something up.
It's not like an exact one-to-one feel, but they start to vibrate pretty intensely as soon as they make contact with something and start to push back a little bit.
So you don't crush stuff?
Yeah, but, I mean, it'll start to buzz no matter what, like once it eventually reaches all the way, but yeah, the idea is so that when you've made contact.
What were your sort of high-level intentions when you started conceiving this thing?
High-level intentions, we wanted to make something awesome that would make the cover of Make Magazine and put the FabLab on the map. So
that was the goal.
That was the goal. We're still awaiting our picture on there. Yeah. But we figured, what's the coolest thing we can build? I mean, we had a robotics committee slightly before we came up with this idea, figuring, hey, what are we going to build? And when Peter had his little tiny idea accepted into the Bay Area Maker Faire, we decided, well, if he's already got a spot in the Maker Faire, we'll just make something much bigger. And he was a big part of the project. He did a lot of the design on the glove.
So when does the Tobor take on the mousetrap and crushing the taxi cabs?
And what?
So when does Tobor take on the mousetrap?
The mousetrap?
Live mousetrap. Have you seen the live?
Oh yeah, I saw that. Last year at the New York Maker Faire.
When do you guys take on crushing taxi cabs in New York?
We're working up to that.
Yeah.
Well, unfortunately, that requires a whole 53-foot trailer to transport. We're only up to the size of a minivan. I don't think we have anyone with a CDL at the FabLab yet.
Well, I think it's really impressive that we got to both World Maker Fairs. And the year before, we went in a van to visit the Maker Faire. Didn't have any idea that we would be participating. I think now we just have to keep on, do more iterations, and just keep making it better.
Yeah, where's our next display? Are we going to the Philly?
Washington,
Washington. Okay.
that's in June.
Okay. Were we doing something in Philly?
Oh, yeah, in Philly, the 2nd and 3rd of January, we're at the Young Innovators Convention at the Philadelphia Expo Center for 2 days.
Any other questions?
Just looking at the gripper hand mechanism itself, I see it's a little on the flimsy side there. How are you tightening a gripper there? What material are you using there?
Okay. These the hard parts here are 3D printed.
Right.
And then the rest of it's cast urethane. So this is urethane. There's no real hinge here. It's just urethane. So that's why it's a little flimsy. We have servos in the back with little hubs on them. I guess we can spin this around. Or you can come up and check it out later.
Yeah.
But they're tightening a string, and the string is attached here. And the string tightens. That's what pulls the gripper in.
Okay.
It's like
I
a
wasn't
pulley
sure which
action.
way you had that going. I was just curious. I found a neat that was like flopping around, but all of a sudden it was still able to make a grip like that.
Yes.
That was impressive.
The flop is kind of also so that this can be knocked into things
Yeah,
without it like
yeah, that makes
smashing
sense.
into pieces or smashing other things into pieces, whichever would happen first.
That's cool.
It's pretty durable. It's been slammed into the ground a few times.
Oh, yeah.
Every time it's come back in one piece. But we designed it to be easily removable. There's a dovetail joint here, so if we want to put anything else on the end, a drill bit or a bit or gripper or a hook or a Nerf gun or something,
Death ray.
it'll be real easy to put on there. And with the wireless communication, we don't have to worry nearly as much about signaling. It's very expandable.
Any other questions?
It's a great technology demonstrator. Any applications that you could tweak it for?
The one that that a lot of people mentioned, and we would agree with, probably like you can imagine something like this being used in construction. It's almost like just a really what it is a very small crane that's hand operated. And so you can imagine something like this being mounted in the back of the truck, and then just having a guy, if he needs to move a whole bunch of pallets of concrete, instead of having to use the fork, it's just a matter of lift. Instead of driving something around or something like that. It's one possible application. Someone said automated in like space exploration and stuff like that on the exterior of shuttles and things like that, controlling the robotic arms that way. Having that feedback in the hand might make it a little bit easier for someone, for an operator to use, as opposed to just kind of going blindly or just using the instruments with whatever the instruments are telling them.
Derek.
I would have to ask them, don't they have things that do those things already? Like you got the one on the space shuttle that's kind of controlled like that. What would make this different? Any different technologies that you're using? For example, I guess the Arduinos are a lot less expensive than conventional stuff and open source, not proprietary. How do you see this as competing against what's out there already?
Well, there's a lot of innovation that can be done on this. This is more of a test bed. That's more of a commercial product that somebody's probably being paid millions of dollars to develop.
There's a platform that you can put other stuff onto as well.
I think we weren't trying to reinvent the wheel. We really weren't trying to do that. We're trying to just do something. So we're not breaking any new ground here technologically.
That's what I thought.
Yeah. We're not even trying to do that.
How can you use this, or what applications do you see?
We're just putting our talents to use, and we're just going to see where that evolves to. But I think it possibly could evolve into something. Everyone that's involved in this is extremely talented. I mean, some of the things that they've come up with, I think they rival some of the think tanks, that are out there right now in certain universities and corporations. So we just need motivation and money. So, but we're going to keep moving along on it. You never know what could come out of it.
Any thought of putting cameras on the front end of that's going to be operated kind of remotely or through maybe virtual reality type?
Oh, absolutely. We had a couple of GoPros hooked up to it at the New York Maker Faire, so we do have some video from the top of the arm here and then back there as well. So since it is wirelessly controlled from the glove, it's absolutely possible that we could design it to be controlled over the internet or through virtual reality if we so desired.
When's the next, what's your, you have a goal for like the next iteration of the glove?
What we want to do with the glove is we want to make the glove easier to put on and take off, because right now it's really hard to find a nice big glove that fits everyone's hands, because a lot of people have very large hands and those tennis gloves are kind of small. So short of contacting OJ, we don't know where he found his big gloves. But we're going to 3D print our own components to also make the things. We have the electronics board in here and electronics board here. As you can see, it's a little unwieldy.
If you want to come up and take a look at this, you're welcome to as well.
The other side there.
The one accelerometer is housed in one board. I don't want to take it apart too much, but if you want to come up and take a look, you're welcome to. One accelerometer is housed inside the glove patch here, and then the other I've attached on the armband. So this is just kind of a ragtag way of getting it on your arm. Ideally, we'll have something that you either like snap on or make it something real quick and easy that you can just slip right on. Not a problem.
Yes, I think that would be one of our focuses. The next focus is going to be to improve the gripper and put some more digits on it. Make it a little bit more like a hand instead of a claw.
Right.
Oh, yeah.
I know bigger's better always.
Yeah.
What I've been told. And you try to pick up cars in New York City and throw them around and it turns into Godzilla. Have you ever thought of making a mini one and making it kid friendly?
Oh, this is kid friendly. The kids in New York City were constantly.
Oh, they're running right up to it. We were.
No, I mean, if the kid could actually operate it. And
they didn't know how dangerous it is, but they can absolutely operate it the way it is, and we have talked about a smaller one, so it's a little bit easier to transport. Because this takes at least 3 people and a significant amount of.
How much does it weigh?
We never really weighed the whole thing. Once you have 2 or 3 people on it, it's not too bad. This is carbon fiber here, so the vast majority of it's like material. This is hollow, except for a couple of wires. It's just the bulkiness and unwieldiness of it. Like
all the weight's in the base.
Yeah, I mean that's welded steel. The hard part is getting the arm into an elevator. We got like 3 inches to spare. We got to fold the thing in a special way and kind of twist it in there.
I could see three or 4 or 5, 6 of them on a table, at a maker fair, and kids playing with them, like they do the lock picking things, That's what I see.
Make like a little like 3-foot one.
Yeah, yeah.
Could be dope.
Yeah.
One last question, and then we'll do 2 last questions, and then after we're done, there'll be plenty of time for you to come up and poke around with it while it's off. Yes?
How much does the material cost to build it between all the Arduinos and the hydraulic arms and the carbon fiber, et cetera?
Actually, well, they're linear actuators. A lot of people think they're hydraulics and pneumatics, but we didn't want to do any fluid or any air, because if you're using pneumatics, it's very hard to hold position because air is compressible. So these are actually linear actuators. These are motors with ball screw actuators. So we can control the position them very accurately, and when you stop applying power to them, they lock in position, which is what we wanted. What did we spend? What's our budget, like 8,000?
No, that's not that much.
Not that much? Was it 8,000 with the trip?
We spent around $6,000 and probably went to 8 with the trip. But the robot itself, the college gave us about 5,000 and we raised about 1,000.
And you didn't tell them about the California trip until after we'd already rented the van and made the plans.
Yeah, him with that.
Actually, the linear actuators are probably the most expensive parts at $400 a piece, and these servos for the gripper were a couple $100. And then there's carbon fiber. Most of the rest of the components,
pretty cheap.
Yeah, aside, the acrylic, a lot of the components you can buy off the shelf. Aside from the stuff that we custom machined, and it's basic raw material. So there's nothing that came off an asteroid or the moon or something that we needed to buy to make this work. We're using a standard ATX computer power supply to power the thing.
One last? Same question.
Yeah.
Perfect. All right, let's give him a round of applause and you can check it out after that.
Alrighty, so our next presenter, we're going to do a quick microphone switch if we could.
Absolutely.
Of course, we have to take off the glove, obviously. Yeah, maybe it might not be the mic. So we haven't. I don't think we've ever done anything like this before. But we're going to talk a little bit about multirotors.
That could damage a light.
Yeah. Good. Let's not focus on that. Talk a little bit about multirotors, and I don't know if anybody saw the news yesterday. The FAA released their ruling that any flying, I think they refer to them as drones, but basically anything that is any UAS needs to be, that is over ½ pound, needs to be registered, not the actual craft, but the pilot themselves, because they are looking at, I forget what the number is, a couple, like 1 million or so sales over the holiday season they're expecting. But our next presenter will introduce himself, his meetup, or the meetup he co-organizes, and give us a little overview of how these multirotors work.
Make sure I get this out of the way.
Oh, and you know what?
Is it on?
Is it on?
Not yet.
It will be, and I'm going to flip that later. That's right. I'm going to flip that later. Go for it.
Am I on? Yep. Maybe. It sounds weird coming back through. Well, it's a tough act to follow, and unfortunately, I didn't get time to prepare a nice video explaining all this wonderful stuff. So you guys got me 3 to 1. So good job. My name's Jeff Shriver. By day, I work as an engineer, and for over 20 years, I've been flying radio-controlled models. And over the last, say, 2.5 years, I've ventured into the world of drones, as everybody likes to call them. For a while there, hobbyists were pretty much anti the word drone because it always had that negative connotation for military applications or spying on you or whatever. But we've decided as a community that we're going to embrace the word. We're going to show everybody that there's a lot more positive than the negative that people have been coming across. And we're going to try and do our best to expose everything we can about the hobby, because there's a lot to expose. I'll start out, I guess, with just getting right down to it. Tim asked me to go over some of the basics, and I know there's people in the crowd that have probably heard quite a bit about these, and maybe some people, this is the first time that you're encountering them. So for those that already know about this, maybe you can teach me a few things. This is specifically a quadcopter, clearly because it has 4 motors. There are hex and octo and tri. You can come up with any type of arrangement, any type of size. They can be made out of almost any material. This one in particular is carbon fiber as well. Wood, plastic, 3D printed, anything you can think of. That's one of the great things similar to your project is there is a lot of open source, not just with the electronics, but a lot of people can pretty much run with this in almost any capacity. You can build your own motors. You can literally build your own boards. You can pretty much do whatever you want to imagine. This was the first one I built a couple of years ago, and it basically consists more or less every multi-rotor is the term I probably will use more than anything else. But more or less they all consist of some basic parts. We got a frame, and there's clearly a set of motors. And these motors are typically brushless motors. We get a lot more efficiency out of those than we do the old brush motors. There was a time when 20-pound batteries and clunky old motors almost put the interest in electrics in the ground permanently. But both the brushless motors and also on the bottom of the battery is a lithium polymer. Most of the batteries that everybody encounters these days is lithium ion. The lithium ions are more longer rate, slower discharge. The lithium polymers have the advantage of being able to discharge at a high rate. So as you can tell, I've got some pretty thick wires on there. Each motor is controlled by a speed control, electronic speed controller, and I'm sorry this is a mess, but this is one of the cleaner looking ones. So if you buy that, this is actually not bad looking. Not sure if I can see too well. Anyway, each of these red rectangles is a shrink-wrapped electronic speed controller. Each one is dedicated to a motor. So each one of those speed controllers is tapped into a power distribution board. Battery ties into the board, feeds power to everything, and then each speed controller will get its power from that equally. Each speed controller is then plugged into, very similar to your Arduino board, this is a flight controller. Okay, it's pretty much the exact same thing that they have on the robot. Most of the time this is an open source piece of equipment as well. You might have a lot of proprietary pieces out there available, but for the most part, a good bulk of the community that is into this at a really intense level, they're going to be swapping and sharing their files on this stuff all the time, tweaking it, making it better and improving on it, and they can do that at a much faster rate than any company can. So as a result, this world of multi-rotors has grown so fast, I just don't know when it's going to be stopping. But anyway, so we got a flight controller, and then there is a receiver. Now this receiver is tied to my controller. So that would be, I send the signal to the receiver. It says he wants to go left So in turn, that receiver tells the flight controller, he's put in a command to go left. The flight controller then determines what proportionality of RPM it has to mix in order to get a left-handed turn. So what it basically does is tell each speed controller how much power to let through like a valve. And then some motors will speed up, some will slow down, and that mixing and constant combination is what will give me my moves. And then on top of that, the flight controller has a series of accelerometers, a lot like yours, and gyros. There's one for each of the 3 axes of rotation. And some of the flight controllers, sky's the limit. This doesn't have what you're probably used to seeing on some of them, an aerial photography platform will have a GoPro or a high definition cam of some sort. This is just a basic model here. I do have some other equipment I'll go over in a second, but otherwise the boards can have additional features, barometers and magnetometers, things that will pick up GPS coordinates. You can also have return to home features. Like I said, the sky's the limit on the amount of features that they can build into these things. This one in particular, I've recently modified from a version that I no longer wanted to go with. It was all gear and had some different gear, so I changed it around and threw some additional gear on that, which I'll go over in a second, and that is first-person view. It's pretty common nowadays to be able to put on a set of goggles or use a monitor and actually feel like you're in the pilot's seat. So I'll sit down in my lawn chair, I'll put on my goggles, I'll take off, and I am sitting right there the whole time, the whole flight. I see what it sees. And I'll show you in a second some of the more adapted quads for FPV. But there's basically a camera on the front, and there is a video transmitter on the back with an antenna. And what that will do is when that's powered up, the signal through the video that is powered will be transmitted through this antenna to my goggles. So basically, the quad is receiving from me, and it's also transmitting back to me with a separate set. And I didn't get to ask you guys, but what frequency is your setup running?
2.4 gigahertz. It's
Okay.
802.15.
All right, so that's off, right?
Yes.
Good, because my controller, I'll hover this, it runs on 2.4, and I don't want there to be a potential for interference. So my controller is on 2.4 gigahertz, and my FPV is on 5.8, so those are separated, and we shouldn't have any problems with that. The rest of it's pretty straightforward. You got wires for batteries, connectors, props, and whatnot. So that's that. You want me to go ahead and give a quick hover?
Yeah, let's try. I'll turn it on.
All right.
So these are the goggles he was referring to. All right, I don't have signal on the goggles.
All right, so at this point, there's our camera. If I was sitting in my chair with the goggles pulled down, I would see that. So as this flies, it can get very quick and nauseating for some people. I point out that I fly in my chair because a lot of people either find it causes vertigo, or as you're flying and going around turns, it causes people to want to lean on their legs. And people have actually fallen down while they're flying. It's a little embarrassing. On a side note, the other thing that the guys have taken to is they've taken selfie to a whole new level. When guys fly with their goggles, everybody has their own style. Some people are very good about just staring straight ahead. They don't know what's going on around them. Other guys tend to move their neck and their head as the quad's moving, and guys will come up while they're flying and not tell them, and they'll take self-portrait selfies with guys having weird expressions on their face. And I've been a victim of that. So. All right, so I'll give it a quick hover. That way you get an idea of the sound, the wind, everything that's associated with it. And then we'll go to the next step. I think we're getting a little bit of that feedback you were getting as well on the signal. So. basically like any other aircraft, I have, you know, my roll, my pitch, my yaw. Whatever the camera sees is what I get to see. Like I said, this is not a race quad, this is more of a general flying around, a little bit of FPV. You can outfit it with some aerial photography equipment if you wanted, but it's really not meant for much than that. Some of the quads that people are probably more familiar with, like the DJI Phantom, that always seems to be the one that's in the news. That seems to get a lot of attention. They have nice streamlined plastic bodies to hide all the ugly electronics. The people that don't want to bother with building or understand, they just want to put a battery in it and go fly. And I think that brings us to the next segment, is the FAA. I'm sure everybody is aware of all the news that's been generated by that. So yesterday the FAA handed down their ruling that they're going to require all unmanned aerial systems to be registered through their pilots. For a while there, that was a focus on the quads and the other multirotors, but they decided to lump all the hobbyist airplanes, helicopters. If it takes to the air, they want it all. So unfortunately, for over 80 years, the Academy of Model Aeronautics has been the governing body in the community for the hobbyists, and despite their efforts, the government still determines that they have the ultimate say on that. So we'll see how that continues to unfold, but like most things, you just get more and more complicated as it goes on. So
what's that going to mean to the future of flying?
Well, I guess it's anyone's guess, because it's gone back and forth on so many possibilities. Like they were going to require at one point that everybody obtain a private pilot's license, which was extreme. They were also going to require that any of the penalties, like for example, if a real pilot who had his license was flying something like this and he had an accident, that they could pull his private license for that. I mean, these are all things that they were bouncing around. Seems like at this point it hasn't gone that far down, but I also wonder, once you start giving a foothold on something, and I don't want to get anybody excited about my views on Big Brother or anything, so we'll just leave it at that. I'll only deal with facts here tonight. So, okay, so that's just...
in regards to FAA, my granddad used to fly model airplanes, and there was, what are the basic rules, not about flying around airports and so on and so forth?
Yeah, right now the limits were 5 miles. You had to stay outside the 5 miles of an airport. And this is all, like, if you got permission, you could certainly violate that, but these were the general rules. It was 5 miles outside the airport, and you had to stay within 400-foot altitude, which, if you go on YouTube, you can find any number of videos where people have decided that they want to do an altitude record, or they want to do some really crazy stuff. And of course, it varies by country, so what one guy does here, another guy can't do there. So, of course, that changes. But those have been guidelines established through the AMA for decades, and up until now, it's worked very well. On record, there hasn't been any official accidents with any of the models that, through the AMA, it substantiated what they were trying to claim. I have my doubts about some of the claims. You've heard stories, pilots coming in the airport and claim they saw a drone at 4,000 feet, and I'm thinking, this thing gets 50 yards away, I can't even see it. These people are traveling 600-700 miles an hour, 4,000 feet, and they're telling me they spotted this thing on a flyby? Maybe they wanted to see it, I don't know. But sometimes I'm a little speculative on what's actually going on with that. Just real quick, I'll give you a quick comparison here, if that's
Oh, yeah.
okay. Let me just...
Range mode.
Oh, you can go back to the goggles. I shouldn't have. You don't have to.
Oh, yeah, I don't think so for this one. I just want to show how this is a race quad. What makes it a race quad is it's smaller, it's built to fly faster, clearly, be a little more durable, and not carry the kind of payload that some of the aerial platforms do. This one, as well as the other one, are racing quads. They come in different sizes. This is designated by its class in millimeters, which is the diagonal distance between motors. So this is a 285 class. That one over there is a 260. And these are generally, depending on, well, let's put it this way. The way I fly, probably in the 40, 50 mile an hour range, but you get one of the top guys on YouTube flying it, and they're easily breaking 80. It's moving so fast that several of the top pilots have actually been accused of speeding up their videos because people believe they can't go that fast, and they do. They are that fast. This one, let's see.
Motors on.
You see how fast it can jump off the ground, and I didn't even hit half throttle. And clearly you can see it's not floating like the other one. It wants to go. And it doesn't have the self-stabilizing feature that the other one has on it. When I race this one, without the, well, let me back up. When you have the an auto level feature, it's one of the safety features that allows you to take your hands off the stick, so to speak, and it will use its sensors and gyros to make sure that it doesn't start to drift off. So if it's floating in the air and the wind comes along, those gyros will sense that it's off tilt. I didn't put any input in, and it'll autocorrect and maintain a level condition. That combined with GPS can allow a quad to literally hover in one spot until you tell it to do it otherwise. This, I don't have any stabilization because I roll, I flip, I go through gates the size of half the door, and I want to be able to do everything that I want. And I don't need the gyros on board fighting me through that motion. So this is basically as freestyle as it gets. If I push the stick hard to the left, it's going to flip. It probably has a I would have to say maybe at least 720 degrees per second roll rate on the top end. So it moves. It moves. So that's just to give you a difference between the two. And there's so many different variations between. The quads can be as big as you want them to, 4, 5, 6 feet across. They can be as small as one of those ones, maybe 20 millimeters. I mean, they fit in the palm of your hand. And it's just your imagination, whatever you want to do with it.
Did you make that one?
No, this actually was a pre-manufactured one. This company produces a lot of FPV equipment, and when they decided to break into the quad industry, I was a little skeptical because I like to build my own. I like to pick out my parts. I like to do my research. But this company had a good reputation, and I thought, you know what, I'm going to go for it this time and just try one. Usually not a big fan, it takes all the fun out of it. But the result of how smooth this one flies, I enjoy it too. But I won't give up on my builds. Now this one here, I built this one. So I buy the frame. It's all 3K carbon fiber, manufactured out of Australia. Decided what motors I want, and I picked my speed controllers. I've swapped them out twice. The flight controller is what they call an ACE32 board. Just happens to be the name of the supplier. Like I said, it's open flight or open source. I picked my own camera and everything, and then basically put it together the way I want to get it to perform the way I want.
How much? Can you say how much that costs?
Well, this, I'll give you an example. The frame here, I spent the money on this frame. This frame was $150 for the carbon fiber. Probably well worth every penny. And fortunately and unfortunately in this hobby, the Chinese have a really good foothold on this. And you can buy this same frame made from a Chinese manufacturer for about $32. So you can see factor of 5, a little bit of a difference. However, one thing I've noticed is the quality is there. A guy that I fly with has practically the same frame, and he's gone through 12 arms. because the way they manufactured it, they didn't take into account the stress concentrations around the holes for the motor, and when he hits, it cracks down every time. Now, has he spent $150 in arms yet? No, but he's probably spent more than that in aggravation every time he has to take it apart and put it back together. So it's all on what kind of gamble you want. A quad like that, the way I have it built, is probably all together here, I'm going to say maybe just under 500. So you buy a decent radio. This radio holds 250 models, so I buy one radio and I'm good for everything. And then the FPV gear probably runs anywhere from 2.5 to 500 for a setup, depending on. But again, that can be used over and over to other models. So once you invest in the equipment, adding to your fleet is not as bad. Another quad, I can have another quad up and running to this quality, probably for just a couple $100 because I have everything else. And then of course you collect parts as you go along, you reuse motors and things, and you Frankenstein it out, and before you know it, you're not buying much at all, but your wife thinks you're spending gobs of money, and you hope that she thinks they all look the same. That way she doesn't really know how many are really in the basement. So that's why I don't give her too much grief whenever she comes home with something from the store. I tend to overlook that a little bit. Like I said, these are the goggles. Comes with a battery, a receiver antenna, and these are a newer version where they've added some additional features. It's still a VGA. The signal is a standard definition. They do have high definition. You can fly through a GoPro. You can use other cameras, but like anything else, there's a trade-off. So if you want higher definition video, there's a greater latency. You have a slight lag. Now, if you're going to just float in the air and look around, a couple milliseconds, probably not at the end of the world. You're going to see it, nothing's going to happen. When you're flying 50 miles an hour, racing other guys around trees and things, and literally 1/100th of a second of reaction time, by the time you realize you're supposed to miss that tree, it's already here. So, and many people, and I will say for a fact that this is probably not too far off, but for those that did enjoy Return of the Jedi, it is very, very similar to racing on the speeder bikes through the forest. It is incredibly exhilarating. And you can take chances because I'm going to walk away from every crash in my life. So,
Crashes into you.
Some people have had that happen, so yes, you do have to be careful. And that's why one of the things that I was talking to Tim was there's one organization this year that is in February stepped up and sort of started to formalize, not as a government or anything like that, but they realized that so many people were enjoying this hobby, but everybody was doing it in their own free way, which is fine. But the thing was, if I race with a bunch of my friends, and then I decide to go race with a bunch in Jersey or in Pittsburgh or wherever, everyone's going to be doing their own thing, and it's going to make for an inconsistent experience. So this organization, GP, which stands for Multi-Rotor Grand Prix, has stepped up and tried to start to organize some standard rules. Not rules that if you break them, you're out of the club or something like that, but more like, here's the guidelines, and if everybody starts to follow, then everybody can enjoy the same consistency in the racing, and then pretty soon, one day, maybe it'll actually become a legitimate sport, and we'll see where it goes from there. I've taken the meetup group, Bethlehem Drone Meetup, which I actually came on board after a gentleman got started, and I sort of took over and organized a series of get-togethers, and we've flown and had a great time. And it's a good day when you come home with a whole pile of busted props. That sounds like you had a bad day, but the more props you have, it's sort of like a trophy in a way. If you've got a pile of props, it means you did some serious flying. So we like to get together as often as possible. And I've actually started to meet with other groups in the Harrisburg area, down New York, like I said, Pittsburgh. And the more we integrate, I think that we're going to be able to strengthen this. And like I said before, put a positive spin on the hobby and start to show everybody out there that we're not peeping in your windows. We don't care what you're wearing. That's to me, that is the most boring thing I can do with one of these, is sit there and just stare at somebody. It's not my thing. So
when does your group meet?
We don't have a regular meetup. What we'll do is we'll try to put things on the calendar based on weather and availability. Generally, we've tried to make something happen at least once a month, maybe twice a month.
Are you always flying when you meet, or do you meet?
Yes. Yeah. Some groups have integrated a night like this where maybe they'll have a build night or a question night, because they realize people coming in the hobby that have never flown. Our guys have been here for years, so sharing knowledge as much as you can do. So we haven't done that yet, but I can see that happening very, very soon.
What is involved in learning how to fly these things?
Other than buying the equipment?
Well, yeah, like crashing them, there's special starter ones that are
there's
really resilient, or
I'll start at the 5,000 foot view and say there's a toy grade and there's hobby grade. If you're interested in trying this and you've never done it at all, there's nothing wrong with toy grade. You're definitely going to be better off because you're not going to have the money invested if you decide this ain't for me. That was great, I did it for an hour and now I'll put it on the shelf and maybe once in a while I'll get it out. Perfect. However, if you start to like it, very quickly, the toy grade is not going to work. It's going to, like anything else, it's going to break. It's not going to be adaptable. You're not going to be able to do much with it. And you might feel like you wasted money, but as opposed to getting into it expensively and then decide you don't want it, it's still a good way to go. And almost anything that you can find at the store, Amazon, anything like that, to a degree, is going to actually be worth its money up front. But if you think that this is something that you want to develop, I think that at that point you talk to somebody that's in the hobby and you're going to find that there are some nice starter packages on the hobby side that are still economical but give you better quality so that as you learn, you don't outgrow it so fast. And for example, a couple of guys at work never did it before and they said, well, what would you buy? I recommended one that was probably in the neighborhood of $50 to $75 more than what he could have got online. But I know that from the reputation of that company, I know he's going to get a lot more life out of it if he has any interest in it whatsoever.
you have to take some kind of lesson. I mean, just buy one of these things, fire it up in your backyard, and I saw some guys try this out on Long Island, and I'm looking at it going, I think it's too windy for them to do this.
Well,
sure enough, it then took off and right into the trees.
If you give yourself the time and the space to do it right, it'll be fine. You can actually learn on your own because most of those have the self-stabilizing features built in, okay? But not knowing that there's limitations, same thing. Guys go, oh, okay, I'm ready. They go outside, they have no idea whether the conditions are right, and I've heard more than one story where it just blows away. Because most of the toy grades are very light. They may only weigh a couple ounces, and for example, they would be exempt from the half-pound minimum requirement of the registration. So you buy something, let's say you see the new Millennium Falcon quad that they have released at Target or something. Doesn't qualify for the registration, you think it's awesome, but that thing has more than 3 mile an hour wind, it's gone. Plus you're going to be fighting and you're not going to understand what you're doing wrong. So yeah, something like that, maybe a small room or gym or somewhere like that would be perfect so that you understand what you're doing and then you can go from there.
So you buy it for a couple $100 or less, these toy grade ones?
The toy grade ones, the average is somewhere around $100.
That's for the controllers?
Yep, the controller, quad, battery, it's all good to go. For $100, you can give it a try and not have too much invested. If you get closer to the 150 to 200 range, now you're starting to get on the low end of the hobby, and that's probably going to give you something that's going to last a little longer if you think you're going to be serious about it.
Yeah, 2 questions. About the gyro stability on a more advanced model. How well could you keep that near a fixed object when it's windy? I mean, how stable really is it?
By your input or by an automated?
Automated.
Each flight controller has, this is where it gets all geeky and sciencey, right? Each controller has algorithms built in, what are called PIDs. I don't know how many people, because this is not exclusive to flight controllers. Anything that has any type of repeatable calculations that's always trying to reduce error and give you a more, I don't know if you guys, you run the PIDs on yours too?
Yeah.
Okay. PIDs stand for proportional, integral, and derivative. For those that know about that, this is probably all going to be boring and I'm going to talk out of my butt like I don't know what I'm saying. Doesn't make me an expert in that area just because I fly these, by the way. But for those that don't know, that is, those are 3 different types of iterative loops that are basically trying to compensate for errors. Proportional is a value that is set in the controller and it's adjustable for present error. So if you're trying to fly to the left, it wants to compensate for that, and it's going to be trying to correct for that on the fly in the present, the inputs as they happen. Integral is the past errors. So basically, it's learning as it flies what you've already been correcting, and it's trying to correct that error as an integration does. It builds a sum under the curve, so it's constantly adding all the errors that have occurred to the past. And then D is the future. It's trying to anticipate what it's going to need to do to fix those errors, and it's already trying to, guess what that's going to be. So those values alone make a whole world of difference in just you trying to manually stabilize it, regardless of wind or not. In this room, I can set those PIDs to a point where I push left and let off the stick and the thing wobbles. Or if I push left, it jerks too fast. So that level of comfort is going to be dialed into your style of flying. But at the same time, that's going to be a result of your inputs. The wind effect, if I have no inputs and the wind blows on it, I'm not putting the PID values in to correct for the wind. That will be set in the gyros the way that they're sensing when you initialize where the zero mark is for each of those. So it's constantly running those calculations against the wind separately from the ones that I'm putting in intentionally.
Could you keep it like maybe within a 6-inch or a foot of where you want?
You either do it visually, or if you want something a little bit more dependable, then you would have a board with a GPS module installed, and then when it initializes, it reads those coordinates, and within the margin of error that particular GPS will allow, you can actually keep it fixed. And then, for example, a return to home feature is a setup where if I fly out somewhere, when it initializes, it knows those coordinates. If I get into a panic, I can flip a switch, and it will automatically fly back and land, and usually there's a tolerance, 10 feet, 15 feet, 50 feet, all depends on the quality and the settings on the gyro and the conditions under which it's flying, the amount of redundancy in the satellites. But yeah, you can basically get something, the more money, the better the equipment that's going to be able to do that.
So I would imagine that your distance is really how far you can get away from the antenna. Is it possible to modify it so it uses cell antennas instead of a remote control?
Yes. There was a gentleman on a podcast I was listening to this week that actually had got back into the hobby and adapted his setup, a transmitter system, to use cell towers in order to be able to fly. Now that is not offered in the industry yet, and I think part of that is because now the cell companies are like, whoa, wait a minute, you're hijacking our towers using a system that's not even appropriate for the hobby. But right now, for example, I'm running 2.4. I can get 3 to 4 kilometer range out of that. Well, that's way beyond visual line of sight. Now, there are also 5.8 FPV systems. That's a high frequency, low power. So if I fly around something, I can't penetrate that. But if I'm going to plan to fly long range, I would not only need to modify my transmitter to have that adaptable range, but my FPV system is going to need that power to go further. So generally, the other systems are 2.4, 1.3, and then even 900 megahertz. The lower you drop on that band, the further you can go and the more penetrating power. So for example, if I was running 900, I can penetrate through walls. So if it goes behind trees or walls that long range, no problem. So there's different systems. Now, what's the price I pay? More money.
Yeah.
So everything is a trade-off for whatever you're trying to achieve. Some guys want to get 10, 15, 20-mile flights. Personally, I think once I go over to the local high school when on the weekend there's no one around, pull up my lawn chair, I have one of these on my airplane, I launch it, I sit down, and I just enjoy the glide, right? And I got my camera set up on a pan and tilt so I can move either my head on a head tracker. I thought you guys were going in that direction. Or I can do it with the controls, and I have it set up on a 180-degree swing, so I'll be sitting there looking through the goggles, and I'll push left on the camera, and it'll look out over the left wing, and I'll give it a bang. It's like I'm flying a real airplane. And I'll usually go out maybe half, 3/4 of a mile, which is fine, because if it gets any further away and I lose control, I just don't want to lose my equipment. And for me, cornfields all look the same after about 5 minutes in the air. So flying out another mile or two to see the same cornfield doesn't do anything. That's why the quads are a little bit more fun, because generally my average height is probably 5 to 10 feet. And yeah, I come along, you hit that ground, and you do 20 rotations on the ground, you're watching it through the goggles, and then you walk away. Oh, yes?
What kind of battery life do you get? I mean, flight time. I imagine it depends per drone, obviously,
It depends on the draw. For example, the speed controllers are going to be matched to what you're trying to achieve on the motor. Everything's going to be adapted so that everything's equalized in a way that you don't have, so to speak, a weak component in the system. Those are 20 amp speed controllers. The ones on my on the small quad I showed you were 12 amp. However, I get 4 minutes on a good day because I'm drawing. I'll give you my readings when I'm done. Combined with the 4 motors, my peak current is sometimes around 64 amps. I'm drawing 64 amps of battery in 4 minutes, over 4 minutes of time.
On 12 volt battery?
No, that's a 16.8. I got a 4-cell running that. And that's why the battery leads are very thick. And I ran one battery through in about 3 minutes one day, and when I took it off the quad, I could not hold it in my hand. It was leaving a red mark as I held it, so you're generating some serious power. Now, conversely, the large quad, I'll put a battery twice as big on it and fly 3 times as long because the type of flying isn't drawing the current that the other one is. So the flying style drives everything. And the nice thing is there's been, with, like I said, open source software on the flight controls, the whole community is always sharing information. So there's been a lot of support on how to calculate your own values. Like you guys are like, what battery should I be running? What speed controller rating? What motor RPM should I have rated for this? And you can run calculation. What are you trying to achieve? What are you trying to carry? What's your weight? How many motor? You can run some basic, electrical calculations 101 and really determine approximately where you should be on these. And it's really easy to do it yourself.
Basically, a whole box of batteries get through the day, basically.
I got a nice charger that I have 4 ports on, and I can charge my batteries safely at what they call 3C rating. The rating of the battery, for example, the one in the larger one is a 2200 milliamp hour pack. So you divide that by 1,000, that's a 2.2, and I can charge that at 3. That's a 1C rating, they call it. So I can charge it at 3C, so I can put back up to 6.6 amps, and it takes about 25 minutes to charge the battery. So you can play with those values. But again, lithium polymer, I don't know if anybody is that familiar with them, but they are extremely volatile if they're not treated with respect. It's probably, it's definitely the most volatile part of the whole setup. If I took my knife and stabbed the pack, it would literally puff, blow up, and spew flames right here in the room, and we'd have a big problem. And that's why when you're flying, some guys will crash, they will dent them, they will nick them, and they've literally caught on fire while they're flying because if they're not treated in the right way, they're going to bite you.
So what's the reality of the Amazon delivery drones compared to hot? Like, is that like a serious thing, or is that like a wishful thing?
I'll tell it like it is. Anything that's toy grade, to me, it's junk. Anything off of Amazon.
No, I mean, so Amazon talking about like delivering packages.
Oh.
Sorry, that's what
that's probably not going to happen for a good while. Not only on the FAA side, but the practicality is the technology is great, but you've got limitations on your payload, your battery, the flight time. So right now you'd have to have an Amazon in like every town in order to be able to service any decent, appreciable amount of area. And I think that until there's another leap made in a way that can produce a more consistent, reliable, long-term or long-distance flight, I think that that's going to be very experimental on a local basis, but doable.
Questions over there, I think?
Yes. Do you ever run into any interference problems where maybe somebody else is running the same frequency, or you're running around a microwave tower that causes you to not control it?
Yep, lots of things. The frequency that I run my radio on is a frequency hopping system, so that isn't so much the issue. I can run on my radio on a 2.4 system. Theoretically, I can run with 100 other guys all turned on at the same time. Nothing, because it's always searching for the next open frequency, and it's grabbing onto that to make sure that before it gives up the other one, it's got a strong one to go on. So that is pretty trustworthy.
Interesting.
The video system, however, is still in its infancy stages, and right now there's only a fixed number of frequencies on the video. It doesn't hop at the moment. So I have right now up to 32 discrete channels, and they're only 20 to 30, let's see, yeah, 20 to 30 megahertz apart. So based on the power of the video transmit, I have 600 milliwatt and I have 25 milliwatt. Basically, as you know from radio signal, that creates a bubble of a certain size based on that power. And even though you're on a discrete frequency, if you've got a power output that's large enough, that can dwarf the next guy over, and you can get like ghosting or imaging from him. That's one thing. If I flew in an enclosed space with a lot of reflective surfaces, I would also get some shadowing because of the signal. Let's say my quad's back there, my signal's going out in all directions. So I'm getting the signal back from the quad in the time it takes for it to travel this short distance in a straight line, but the signal is also sending out in other directions. It bounces off that wall and arrives to me a slight lag later, and now all of a sudden I start seeing double imaging, and it comes out blurry, it comes out very disorienting, so that's another thing. And then of course if other guys are right on top of you, so the materials and things like that definitely play a part in that.
Do your controllers take into account latency from where you are to the device?
In terms of the video signal?
Well, video or control, or the actual controller in the PIDs?
The controllers, not so much, but the video signal is a standard definition signal, as I mentioned earlier. And one of the things that results is the lower the quality of that signal, the less latency. So when I run my standard definition on my racing quads, I'm getting practically instantaneous feedback. I mean, so small that there's no possible way that the way I'm reacting and what's happening out in the field, there's any amount of difference. However, guys that want to run a high definition system, like there's a system called Lightbridge by DJI that they've released. High definition runs you about $1,500 or so for the transmitter, but you get HD. Problem is, that comes at a price of lag. So if you just also decide to run through your GoPro, a processor, it takes time, more distance to travel internal to the camera, and then output, a GoPro will give you enough lag. So most guys racing will actually opt for lower quality video so that they can have faster response.
And you can, I think I know the answer to this already, but you can program flight plans in this. So, if you had GPS coordinates of where you wanted to go, if you had
Again, based on what type of flight controller and setup you want to put into that, guys can use their iPad, bring up a Google map, and actually touch the screen, and then it'll plan a map, hit start, and then the thing's autonomous. That's probably the most boring way to fly. However, I do see the practical applications. I mean, this technology has already been proven in so many industries. I can't wait to see where it's going to go next. They've used it in firefighting activities with FLIR cameras to detect hotspots in burning buildings, to actually give real-time feedback as part of the crew to the chief, so he can keep his guys out of danger, so that when they're fighting fires, they're not walking into traps. I mean, I don't know how you can have an argument against that. They've used FLIRs to locate people missing in the woods after the sun goes down. They pop up like a beacon, and they locate them. No risk to anybody. It cuts down the time. It's a lot more reliable. They've experimented with drowning victims. They've determined that the response time of a quad launched and dropping I think it carried 3 on the one I saw, but to drop a life ring to a drowning victim was 1/3 of the response time of the lifeguard to get out there. So the nice thing is, you go out, you drop the ring, now the lifeguard still goes out, but now that guy's got a fighting chance while he's waiting to be rescued. And it just goes on from there. Surveying, for example, this is where having those automated points, if you've got to do a parcel, they've got software that is incredibly integrated with the CAD and the BIM and the modeling, and they'll map the points, and they'll be able to actually take enough photographs in 3D with the camera that they can actually come back, load all that in, it'll compile, and it'll come back with a 3D topo map, and they can do cut and fill calculations without ever sending anybody out in the field, and probably like a tenth of the time. And it's probably more reliable too. So they're just incredible on what they're doing with these things.
Couple more questions? You got one there, one there? Yep.
Besides the cameras, what else? Is there any other attachments that are common in the drone?
Let's see. The camera's really popular because everybody wants to see everything from a different view. Do you have anything in mind?
Yes, I did.
Funny
you should ask.
Go ahead.
I want to make one that is. Sorry,
Yeah,
I want to make them so that you can play paintball in the sky.
The FAA will not like that.
Shoot projectiles at each other and have teams and Call of Duty in the air.
You can do stuff. Actually, on the realistic lighter side of that, they did have a couple helicopters, toy coax helicopters you could buy. I don't know if it was Airhogs or not. They actually had sonic or laser emitters or whatever. Anyway, it would fly around. These were sold in pairs. And if you could aim at the other guys and press the button and send a signal, it would power his down and drop him out of the air for about 5 or 10 seconds until they could come back up. Now that's...
I have those.
Okay, right. Now, on the other side of things, the guys, again, YouTube it, the guys have done all the way up to 50 caliber. They put some serious firepower on these things, and they shouldn't.
On a serious note, you could have like target, instead of racing all the time, you could have target courses. You know, like you're going on a firing line and stuff pops out and you got to get through the course as fast as possible. What about making it big enough in 10 years from now, or whatever it would take, to replace medevacs?
Yeah, absolutely.
And just to take people to the hospital.
Absolutely.
Instead of trying to clear the space. There was an accident today on the news. They had to close the road for 2 hours because the helicopter was coming down. I think you could just put the body in there, like kind of like the Coast Guard guys do, you know, with the case. And they
get with Amazon on that. Maybe
reel them up.
Yeah, there you go.
But no, they've actually, some guys have experimented with some of the larger hobby grade. They've built, you know, much like you guys are in a lab experimenting with that, and they built frames, and a couple of them, they've been pretty successful.
I think Jeff could probably get that done before Christmas for me at the FabLab.
Some of these motors are, you know, they look exactly like that. They're just larger scale, and they can build a frame, and some guys have tested it. So I absolutely.
Where do you see I mean, that's my last question. Where do you see this in 10 years? Like blow our mind with something in 10 years. Where this is going?
I think all of the technology there is going to be replaced with some other version that's going to make this thing look like I was driving Fred Flintstone's car. I don't think motors are going to be there. I think we are going to see modern versions of what you saw in Terminator with the Hunter Killers. I think you're going to have some kind of very advanced propulsion system, and I think your battery is going to be replaced with some type of contained energy source, maybe like Iron Man. I think if you could get a source of energy like that, and you could get a device to output it, I think you could definitely propel this into an era that could actually exceed where our modern aviation is, and then they turn around and reverse engineer and bring our aviation. I don't think aviation, as we know it, is going to lead. I think this stuff is going to go faster because you've got the open source, you've got the community, and if, I'm going to say it, if the government would just stay out of certain things to a degree, you would allow this community to develop this. What you're going to do is you're going to stifle a lot of creativity, and you're going to make people afraid to come out with new ideas because they're going to be targets. Not literal targets, but you know what I mean. And I think that when you allow the community to run a certain creative aspect of that, I think that's where you get development faster. I mean, it's incredible in just 1 year alone how much the technology has changed with the flight controllers. I can't even get into it because I'm just bore everybody to death on what excites me about it. But
I think there was one last question in the back. You already answered. All right.
I have a question for Tim.
Okay.
How come software only gets 3 minutes and hardware gets 35? Actually, I was thinking that was.
Let's give a round of applause for our All right, I won't bore you too much with what I have to say.
because we're pretty much out of time. But hope you enjoyed that. I think it seemed like it sparked some interest there. And I want to encourage you guys to take a look at the meetup site going forward for what we have planned for 2016, which is really nothing at this point. But if you look at the site, it will magically appear when we plan it. Just a few notes though on 2016. We are going to have, as far as I know, LV Hack again, the hackathon in the spring. We will also, we did not have a startup event this fall. It was postponed to the spring too, so that will also happen sometime early next year. If you want to know more about that, like I said, go to meetup.com, join the meetup there. We will definitely announce that through the meetup site, as well as, honestly, if you're on social media, we do basically nothing on Facebook, so if you want to know what's going on from a more real-time aspect, if you're on Twitter, just follow LVTech, and usually we let everybody know what we're doing there. Let's see what else we have for 2016. If you would be interested in helping with some of the stuff that we do, let me know. Shoot me an email, tim@lvtech.org. We don't own that domain. tim@lehighvalleytech.org. So just shoot me an email there. Would love to put together some other stuff, but need some help doing it. So if you want to volunteer, just shoot me an email. That'd be awesome. And the other thing that anybody can do, even if you don't want to volunteer, which is okay, I get that, we're all busy. But as you look around, you see who's here. So find someone who's not, and invite them to one of the meetups early next year, because we'd love to see more people out here. Because this stuff, I think this stuff is pretty cool. What did you think about tonight's presenters? Pretty cool? Everybody's like, So with that, I will just let you all grab another slice of pizza if you want it. Come up here, take a look at some of this. Everything's off, right? Everything's off. It's off. Take a look at some of the cool stuff. Grab some pizza. I think there's some stuff over here if you want to look at more of what goes in the electronics of the multirotors. See you next year.